The use of forces method to find forces in statically indefinable mechanical systems is article number 3.2 from the book Mechanical Systems Calculations of the Marine Facilities. When deciding the issues of mechanics, finding the support reactions and the developing the balance equations of the mechanical system to find the forces acting in the elements of mechanical systems, we consider first of all is the system subject to research, is the system system statically definable, do the number of variables not exceed the number of the balance equations, or the system is not statically definable as if, for example, for the integral system, the number of variables could be more than the number of the balance equations. So first of all, we have to decide is the system statically definable or indefinable, changeable geometrically or inchangeably, variable or invariable. It's about the same. Yes, and when we have statically indefinable system, for example, we after that can use the usual approaches of mechanics. Usual approaches can be the so-called forces method or the displacement method. So first we will look at forces method, and to use forces method, we have to determine what is the main system for the assigned system. So let's repeat that assigned system is statically indefinable. So degree of freedom of the system is less than 0, and the degree of static indefinability is exactly like 1 or more than 1, as degree of static indefinability is equal minus of degree of geometrical freedom of the mechanical system. So to use the forces method, first of all, we have to find what is the main system for the assigned one. The main system is for the assigned one is corresponded statically definable system. For the forces method, the unnecessary links of the assigned system are to be changed by the unknown subject to find forces. So this is a forces method. It can be the options of the main systems for the assigned system mechanical. So as here, please see, for example, we have assigned system. Assigned system have the rigid embedded in point A, the rigid corner, and we have the fixed hinge here in the point B. We can substitute the fixed hinge by two supporting links. Supporting links, each one is like the simple hinge, but together this fixed hinge. This kind of the support provides the forces, the force of the two components in the point B, but the bending A provides us the support reaction of two components in the point A and the supporting moment in the point A. So we have actually 5 unknown variables as the two components in the for the assigned system, 2 components in the point B of the support. We have 2 components of the resulting force of the support B, and 3 components in the point A. We have the resulting force as well as in the point B, but as well we have in the point A the one component of support reaction is the bending moment in the point A. So for the forces method use, we have to change the supporting links like here by the unknown forces. The options can be of the main system. This main system is statically definable. We have 2 times statically indefinable system, as we have 3 equations of balance. For the flat state on the plane, we have the balance that for the balance of the mechanical system, the projection of all forces on the abscissa axis have to be equal to 0. The abscissa, the projections of all forces, total, I mean, on the ordinate axis have to be equal to 0, and the rotating moment of all acting moment of all efforts in the plane have to be equal to 0. This rotating moment is the scalar when we consider the plane when we consider the flat state of the mechanical system. And the first option of the main system could be if we remove, let me please remind that we have 2 times statically indefinable system. So we can substitute the supporting links in the point B by 2 forces, x1 and x2. And next we cut out the supporting links. And this rigid corner A, the corner and B, in the main system, in the first option, is statically definable as of the support reactions under the external load and applied unknown load subject to research using the forces method. The supporting reactions, we have only 3. We have project components of the resultant in the point A on the components projections on the abscissa and ordinate axis 2, and we have the rotating moment 1 more. So 3 balance equations and 3 components are unknown for the main system if we assume that perhaps we know the forces x1 and x2 acting on the point B. Next one, support removed of the main system for the assigned system. For the assigned system, we can do the main system by the another way. We can remove in the point B not 2 links, 2 supporting links, but just only 1, the horizontal, for example, and substitute this by the support reaction subject to research x1. And besides, we remove the rigid embedding in the point A by the fixed hinge here, fixed joint. So to do that, we have to define here that have to be the bending moment. And and I want to underline first that all of the unknown efforts acting instead of the removed links by when the creation the main systems of the assigned system, we denote as x's for that. This is just the upper cases x's. We have x1, x2, etc., xn. So how many the degree of static indefinability we have n. The efforts instead of the removed supporting links. One of the efforts could be the rotating moment in the embedding A instead of the when we change the embedding by the fixed hinge making from the assigned system the second option of the main system. So this is statically definable system as well. And we have 2 unknowns subject to find the force from the right leftward directed to the point B and the bending moment in the point A. Assume that perhaps would we know the efforts x1, x2, force x1 and the horizontal component of resultant in the point B and the bending moment xa, x2. This, if we would know, the main system in the second option would be statically definable. So we have to first, for the use of forces method, to find what is the main system. Main system is let's repeat, statically definable system instead of the assigned system, statically indefinable. In the considered case is 2 times statically indefinable system. Okay, the third option of the main system. We can just leave just that supporting links in the point B the same as in the assigned system, but we can remove 2 links from the embedding in the point A and remain just only sliding 1. So the sliding 1 link provides in this definite 1 case just only the component vertical of this resultant in the point A. So the unknown remains the horizontal component in the sliding hinge, and the unknown is the rotating moment in the embedding X, assuming that perhaps would we know this is subject to find the x1, the horizontal component of the resultant force in the support A and the bending moment in this point A. Assume would we know this magnitudes x1 and x2? In this case, we would consider this like we will consider this like a external load, like F maybe, like force F, and this would be statically definable system. Or A, just only one remains, force vertical for the hinge A when we substitute the embedding by the sliding hinge and two forces. And here we have a resultant with two components. Yeah, 1, 2, 3 components we have of the supports for the main system. And 3 balance equations is enough to find for the main system, enough to find 3 equations to find required efforts in the supports. Okay, we can do another approach. For example, we can remain this supporting links in the point B as was assigned in the assigned system. We can remain for the embedding another one link as for the force A to provide two components of the support resultant reaction. With not only we have to assign the bending moment in the point A, and we cut this place and install here, install the joint hinge in the point in the corner. The corner will no longer be for this kind of the main system, for this option of the main system. This point will no longer be the rigid corner, this hinged corner. Yeah, just like truss we have now, and is the node of the truss. And we substitute this joint by the rotation moment instead of the removed rigid property of this corner. We have the same as the assigned system. We have new system the same as the assigned one, but if we the rigidity in the corner of this mechanical system assigned, remove the rigid corner by the hinge, and with two assigned unknown subject to research, the symmetric rotating moments to the upper one rod and the vertical rod here. Yeah, this is a statically definable system, and with two unknowns. One unknown is with two efforts, with not the removed links supporting the fourth link effort is the bending moment in the supporting point A, formal embedding, and the bending moment in the joint instead of the rigid corner. And one more option, we can say main system 5, we can just remain this embedding as a choose B assigned system. We just put the hinge here in the rigid corner of the assigned system. We put the hinge as the previous one, main system option 4. And we as well put here two symmetric bending moment instead of the rigid corner, transmitted the bending from this one vertical rod to horizontal one, or from horizontal to vertical is not so much important. But here we just assigned this bending moment as a subject to find. And instead of the fixed joint, fixed hinge B, we put here just only one link as a sliding joint, and put here as a subject to research a second variable of the forces method in the 5 option, like we have to find the vertical component of the efforts in the hinge x1. Okay, and I just want to underline that the last one option of the mechanical system not possible to use due to the fact that here we have 3 hinges, 1, 2, 3 on the same straight line. That just was actually not a system, mechanical system, statically, geometrically unchangeable due to this. When we have 3 hinges straight line, each one very small gaps in the hinges, for example, can cause the displacement of the point B due to the property of the hinges located on the same straight line. So this is instantly changeable mechanical system. So it can move here for much more displacement than the gap in the hinges, in the 1, 3, 4 hinges, 1, 2, 3 hinges. So we can consider as a main systems for the assigned one only first option, second, third, and fourth, with no the fifth, as we have to aware to use a mechanical system consideration if three hinges are on the same straight line. This is an instantly changeable system. Okay, so that is a recommendation. The use of forces method to find forces in statically indefinable systems, choosing the main systems of the forces. What is the ways to eliminate unnecessary connection when creating main systems? First is discarding support connections by completely removing individual supports or replacing them with the supports with fewer connections. The reactions acting in direction of the discarded connections are the main unknowns of the forces method. Okay, the second, the placement of hinges in intermediate sections of the rod is used in transverse connections corresponding to these bending moments. And the third, cutting the rod eliminates three connections corresponding to internal force factors: the bending moment, transverse force, and the longitudinal force. Okay, so if we just do the section method and we just the cut of the rod, just at the point of the cut and consider two parts separate, we have three variables more to find, because this rod transmitted the longitudinal force, transverse force, and the bending moment. So in this case, it's not so much, in the considered case, it's not so much appropriate as we have only two times statically indefinable system, and if we'll do cut, we have not two but three variables. So for us, we can use the first and the second recommendation. In particular cases, cutting out rotated hinge releases two connections, and cutting a straight rod with hinges and the releases one connection at the ends. Okay, so would we please consider the mechanical system shown in the figure, on the figure 3.2.2. This is two vertical rods and rigid corners C and D, and we have rigid points E and F, and the hinge K in the between of E and F, and we have two hinges in the points G and H, connecting the horizontal rod to the vertical ones. Would we do the section method, and we sect by the vertical line? This is a flat statement, so it's the section would be not the plane but the line on the plane. So what we have, cutting the rod with rigid ends and with not hinge inside, we have three new variables subject to find: x1, x3, and x2. This is all when doing the main system from the assigned statically indefinable system. And we have the symmetric on the other side, symmetric variables. This is efforts acting in the connection, assuming it cut by section. If we cut the hinge, because hinge do not transmit the bending moment, so we have only two reactions: longitudinal and vertical shearing force, and the longitudinal force in the rod EF. So this is to the subject, how many variables we can put as a subject of the finding by forces method for statically definable system, cutting the other mechanical elements of the mechanical system of the rods, the straight rod with no hinges rigidly connected in the corners of the rod, rigidly connected in the corners, but having the intermediate hinge and the rod connected by two hinges in the corners, G and H, for example. In the last one, rod, we have, when we cut it in the middle and as a place inside, we have only longitudinal force, as we have two hinges, and that's why this rod is not under the action of the shearing force of bending moment, as we have two rods, and we do not have load on this rod itself. So if load can be here, it could be another one way. but we have no load, and that's why the rod is only under the action of the longitudinal force. So the cut of this rod gives us only one variable. Yeah, and we cut this all this all mechanical system together. We have 1, 2, 3, 4, 5, 6 variables new, and we have the symmetric diagonal symmetric here, and just symmetry here for the GH. Absolutely necessary connections and conditional necessary connections. When we do the main system of the assigned system, we can remove the supporting links, and the supporting links could be absolutely necessary or conditionally necessary, such as in the considered example. We have points A and B. This is statically indefinable system. This is one-time statically indefinable system, as we have 1, 2, 3, 4 unknown forces in this mechanical system, but we have 3 balance equations, so 4 required forces and 3 balance equations. We have not enough balance equations, so we have to have one more force to be assigned and found by another way, not only by the balance of this mechanical system. And first of all, to use the force method to determine the forces and supporting actions and the forces inside this frame, we first have to do the main system of this frame. The main system, in definite one case, we can say about 2 options. Yeah, we can remove one link, this one supporting another one. So each of 4 links we have to remove. What as the system is just appropriately symmetric, if we not consider the force only, but the supports. So we will consider only the change of links in the point B. And in the point B, when we remove the left one, this system remains geometrically invariable. So, and the statically definable geometrically invariable. But if we remove the vertical link in the point B, but remain the horizontal one, this system would have 4 hinges. 1, 2, 3, 4 hinges. Remains on the one straight line. So this system is instantly changeable. Actually, it has the degree of static indefinability as equal to 0. Yes, it is, but due to the contradiction arising that we cannot use the main systems do with hinges on the same straight line, because the gaps in the hinges can cause the displacement in the points when the hinges are on the straight line. So conditionally necessary connection which removed the statically definable system remains geometrically changeable. Yeah, this is horizontal connections, each one of 2 in the point B or in the point A. These are the conditionally necessary connections. And the vertical links in the supports A or B are absolutely necessary connections, which elimination turns a statically indefinable mechanical system into a geometrically variable. Geometrically variable in the sense of instant opportunity of the geometric variability of the system, of the main system, of this one second option made of the assigned system. Okay, questions and comments. The main system of a statically definable mechanical system for which the equations of compatibility or deformations are compiled. For the forces method, first of all, if we have to decide the statically indefinable mechanical system, we have to do the main system. Main system is for the assigned system is appropriate statically definable system, which for the we remove some supporting links to make a statically definable system, and we substitute the links by the forces subject to find with equations of compatibility of the deformations of this force method. 3.2.2 extra, the redundant connections of statically indefinable mechanical system. Yeah, to do the main system, statically definable system of the sign system, we have to find the redundant, the extra connections of statically indefinable mechanical system. And we have to aware the opportunity to, when doing the system statically definable, the option of if the some joints of the main system would be on the same straight line. 3.2.3, the options of basic the main system. Usually we have not one option with the main system, but we have a few options. It depends exactly on the number of static indefinability of the sign system. Yes, but as more is static indefinability, so more can be the number of the options of the main system. But if we just only aware to do the main system mistakeful with the hinges on the same straight line, they would not be same, despite the fact that the system with the joints on the same straight line could be statically definable, but due to the properties of location of hinges on the same straight line, it can be instantly changeable. 3.2.4, the ways to eliminate unnecessary connections when creating main systems. We can cut the unnecessary connections, but we, as in the question 3.2.5, conditional unnecessary connections in mechanical systems, we have to understand that could be conditionally necessary connections and could be absolutely necessary connections. And conditionally necessary connections, if we remove this connection during the main system of the assigned statically indefinable system, for the conditional necessary connections, the main system remains geometrically invariable. If we remove the absolutely necessary connection, then perhaps the system will be instantly variable. Indefinite case, like in the case of location of all joint of the main system on the one straight line. Thank you.